So our next topic will be determining the translation vector. Okay, so example number 1 says, determine whether a translation maps triangle JKL and to triangle JKL prime. If so, find the translation vector. If not, explain why. So let us look at figure 1. So this is the original figure, and this second figure right here is the translation of the original. In order for us to see whether the translation maps the two triangles, we're going to look into their translation vector. So how does this translated? Okay, so I'm going to look at their corresponding vertices. So J corresponds to point J prime. So how it was translated? Let's try to find out the translation vector. So it moves 1 and 2 to the right. So I'm going to write here your x is 2. And then it moves 1, 2, 3, 4, 5. Okay, so 2 and 5 is the translation for point J. What about L? So let's look at L right here. How many units it was translated to the right? So 1 and 2. All right, so this is 2. And then 1, 2, 3, 4, and 5. So there is a translation of 2 and 5 as well. Now let us look at point K. So vertex K. So how it was translated to the right is 1 and 2. Okay, and then up 1, 2, 3, 4, and 5. So as you can see, the translation vector are all the same for all the vertices. That means the translation maps triangle JKL and to triangle JKL prime. Okay, so this is a translation. How? Because the vectors or the translation vectors are all the same. All right. Now let's look at example number 2. So it's the same. Determine whether a translation maps quadrilateral LMNP into quadrilateral LMNP primes. Okay, so if so, find the translation vector. So let us try to look at the translation vector. I'm going to start off with this is the original figure and this is the translation of that figure. So I'm going to take point P first and how point P prime is translated. So 1, 2, 3, 4. So it is translated 4 units to the left. So that will be -4. And then 1, 2, 3. So we have -3 down. Okay, 3 units down, so it means -3. So that is how it was translated. Now let's look at point L. So point L to L prime, we have here 1, 2, 3, 4. So it is also to the left, so -4. And then 1, 2, 3 down, so that is also -3. Now let us look at point M and M prime. So 1, 2, 3, and 4. So this is also -4. And then 1, 2, 3 down. So that will be -3 as well. Now let's try to look at N, how it was translated. 1, 2, 3, 4. So to the left is -4. And then 1, 2, 3. So -3. So this is the translation vector that we are looking for. They are all the same. That means this original figure is translated to this figure number 2. Okay, so this is a translation, and these are the translation vector. Translation vector. Okay, so as simple as that. Don't get anything wrong with it as long as you know how to count the number of units, to which direction, and yeah, that is all about it. All right, so let's look at this example. So again, you are trying to um, find the translation of number 5, 3 units to the left. So basically in this example, you're just going to follow the direction. It says to translate the figure 3 units to the left. So we're going to look at the vertices and I'm going to translate it 3 units to the left. So this is 1, 2, and 3. So this is the x prime. Alright, let me just erase some of the markings so you won't get confused. And then we have here point y. Then we have to move it 1, 2, 3. So this is your y prime. Okay, and then your z, point z is 1, 2, 3. So this is z prime. So if you're going to connect the dots like this is how the figure will look like. Okay, so this is the figure that you will get when you translate the original one 3 units to the left. Alright, now let's move on to number 6. The translation vector is 1 and negative 2. It means that this is 1 means this is your x going to the right, it's positive 1. And a negative 2.5 means to the y-axis, but it goes down because it is negative. So let me just translate E first. So it says 1 to the x-axis, so going to the right 1 and 2.5 down. So this is 1, then 1, 2.5 is somewhere here. So your E prime is along this location, and then your D prime would be 1, and then 1, 2.5 is somewhere here. Okay, I hope you could follow. So this is your D prime, and your G would be 1, okay, 1 to the right and 2 down, 2.5 down, 2.5 down. So this is your G prime, and your F would be 1, and then 1, 2.5 is somewhere here also. So this is your F prime. Now let us connect all the dots to see the translation of this figure. So this is the translation of the original figure. Okay, so that is how it looks like. Let us clean it up so you can see it clearly. Okay, so this is how it looks like. Oops, it was removed. Let me connect them one more time. So this is the translation of DEG. Alright, so for number 7, it's having translation vector -5, -7. That means your x will go to the left and your y will go down. Okay, so from S, we are going to count 5 units to the left. So 1, 2, 3, 4, 5, and then 7 down. 1, 2, 3, 4, 5, 6, 7. So this is S prime. And then same goes with this 1, 2, 3.4, 5, and then 1, 2, 3, 4, 5, 6, 7. So this is your T prime. So when we connect the line, this is the translation of that figure. Okay, I hope you understand, and let's move on to the next topic, which is still determining the translation vector. So for this example, we are asked to name the image of each point after the given translation vector. Okay, so the translation vector here is 5 and -1 for number 8. And the points of F is -3 and 1. So if this is what the questions will be like, what you're going to do is to just add the points. Okay, so plus 5 and -1. So the image after this translation vector will be at, so -3 plus 5 will be 2, and 1 plus -1 will be 0. Okay, so the translation of this point -3 and 1 will be at 2 and 0. Okay, and same goes with this example number 9. Just add negative 2 and negative 5 to the point. So we have here 2 and negative 7. All right, so this is the translation of Q, or this is what we call the Q prime. Here we call it the F prime. Okay, and this, for example, we have to add 3 and negative 0.5. So if you're gonna add this, we'll have 12 and 1. Okay, so this is your P prime. So as simple as that. This is not very difficult at all.